All right. Hopefully you can hear me now. I'm meteorologist Ross L. And this is Getting Schooled. This take number 2 because we had the issues just a few minutes ago when I tried to fire things up. Couldn't hear me once again. So let me know if you can hear me, or hopefully you're letting me know if you can't hear me. The mic is on. I got the green light here, so hopefully it is working this time. We had the same issue a week ago. I just rebooted everything and it seemed to take care of it. So hopefully that is the case this time around. So let me go ahead and get logged in over here and we'll get started shortly. Again, just hoping that the audio is working out all right. All right. And as always, let me know where you're watching from today. Certainly a beautiful day outside, and next week we've got some actual warmth, maybe some heat that'll try to move in, and it's going to really work out well when it comes to our next theme, which is all about summer. So next week we talk about that. Today we are going to finalize talking about world weather, and yet we're talking about Toledo weather history, Northwest Ohio in general. So I'm excited about this because I like extreme weather. Anything that's interesting weather-wise, I love it. Whether it's happening in the future, whether it's happened in the past. And in this case, we're going to talk about some of the biggest storms that ever hit Toledo. And I guarantee you, we're going to talk about stuff today that mom or dad and grandma, grandpa don't know about. I'm sure we've already talked about the blizzard of '78 and the blizzard of 1918 and some of those other systems, but there's some others in there that have produced more snow than those big blizzards. And we'll talk about that today. Next Monday, we'll talk about the changing seasons. We're getting closer and closer to the end of spring, the beginning of summer officially coming up in June. Why did the seasons change? What's behind it? It's actually pretty neat. What directs it? How Earth is tilted has a lot to do with why we've got all 4 seasons. So we'll talk about that on Monday. Tuesday, it's all about tropical weather. We have gone this entire time and we have not talked about hurricanes or tropical storms or any of that. It's all going to be tropical weather on Tuesday. And Wednesday will be about extreme heat and anything else that you want to know. So you start to think, if there's a weather topic that we have not talked about so far and you don't see in this list and you want me to talk more about it, not just answer a question about it, but actually go more into detail about it, let me know. Let me know, and we'll try to incorporate that next Wednesday on our final day. But again, for today, we are going forward here with what is certainly some more interesting conditions here when it comes to some of these extreme stories that we're going to be talking about. So I'm going to go in chronological order, meaning we're going to go from way back at 1900. I'm going to work our way up to closer to present with some of these bigger storms. But this is one maybe you haven't heard of before. And it is the Toledo, the biggest snowstorm ever recorded in Toledo. And it wasn't the blizzard of 1978. No, it was this storm. The only storm that's ever produced 20 inches of snow or more in Toledo actually happened all the way back. And on February 28th, pretty late in the season, to March 1st, 1900, it was 120 years ago, a little more than 120 years ago, we got 20.2 inches of snowfall, almost 2 feet, and one single storm. And some of the historic photos from back at that point are pretty neat to see, to say the least. All right, storm number 2, this was in 1913, also in March. You'll see March is, I think, the wildest month out of the year because we can get snow, we can get severe weather, we can get big windstorms. In this case, it was a severe thunderstorm that rolled through Toledo, and it was on March 21st. It was either the first day of spring or it was within a day of the first day of spring, 1913. And so this is still going back 170 years ago. But look at the winds here that came through. This is a stronger wind gust than what would be a Category 1 hurricane. 84 mile per hour wind gusts came through with that storm back on March 21st, 1913. So it was a line of severe storms that swept on through. Again, you don't find a whole lot of stories about this. It was 107 years ago. I don't think anybody living today experienced or remembers this back at that point, but it was still a pretty remarkable day in Toledo weather history. All right, this is one that I find very fascinating because the blizzard of 1978, as I've talked many times about, is this benchmark storm. And yet, it's not the only time that we have records of a storm coming together like 1978. In fact, almost exactly 60 years earlier in 1918, so 102 years ago, January 12th, we had a blizzard come in. This thing put down 6 to 12 inches of snowfall. not that far off from what we had in 1978. And here's the kicker. It produced 58 to 63 mile per hour winds, not just for an hour, but for 15 consecutive hours. Hard to imagine. And that was a powerful, powerful storm that came through in 1918. So has a blizzard in 1978 happened before? Pretty much, yes. It was 1918. This was the old-time weather maps, which I find really interesting. And Toledo was a very important city on these weather maps back in that day, because if you look out west, there still weren't a whole lot of areas where you don't see little dots on the screen. Today, we have weather observations all over the place, but Toledo is a really important spot in the Great Lakes in the Midwest. It was a big enough city that was able to report some of those conditions. So in this case, we had basically the same type of setup that came in like 1978. Here's Toledo, kind of circling in on that yellow dot. We had a storm down to the south, an area low pressure, storm to the north, and this cruised in, and this one came up to the south and bang right over top of Toledo, and then it ended up going to the north and spinning around, and that's where those strong winds were at. And it just socked the whole part of the eastern part of the country in some sort of impact. But it was the exact type of scenario, same storm track, everything that happened during the blizzard of 1978. And the impacts were very, very similar. And the only thing that was different is in 1918, the way of life in Toledo was much different than 1978. So we didn't have cars and folks traveling nearly as much in 1918. And so things really started to kind of come to an end. By the way, 1918, also the last time we had a major pandemic to the quite kind of like what we have right now with COVID-19 and the coronavirus. And the reason we're all staying at home and doing the social distancing thing was also happening in 1918 to going into the following year in 1919. So that was also 102 years ago. Let's go ahead and move on to the next storm. So the 1918 one, definitely a big deal. This is 1936, and this would have been absolutely miserable to live through. July 8th to the 14th of 1936. If you don't like heat, you would have hated this week. It was the hottest week ever recorded in Toledo, and it really wasn't close. 6 days in a row, well, not in a row, 6 days out of 7. So we had that whole week stretch, 6 out of the days, we had highs in the 100s. Actually, the highs on the coldest day that week was 99. The hottest day was 105. By the way, 105, the hottest temperature ever recorded in Toledo. And it gets hotter, actually. Out towards Defiance, Napoleon, and Wauseon, we had temperatures in the 1-teens, actual air temperatures up to about 113 degrees. It was remarkably hot. In fact, I didn't show you guys this earlier, but if you can see, if anybody's interested in some of this weather history, and you can find this book on Amazon or eBay or something, get it. It's one of my favorite books, Thunder in the Heartland. This whole book is nothing more than weather history of extreme storms in the state of Ohio. In fact, I didn't even think about doing this earlier, but could probably find, let's see here, 1918 heat. Let's go to 1936, and it'll have a map. Right there, it was Defiance and out towards Paulding. They were at 111 degrees. So I don't know how well we can see that map, but it was about 104, 105 in Toledo. Even the lakeshore was in the hundreds. A lot of 111s across the state. The state record was 113 degrees. Absolutely remarkable how hot not only that day was, but this was the Dust Bowl era. And so that whole setup with drought and the Dust Bowl and the extreme heat didn't just impact the plains, but it impacted all the farmland all the way towards Toledo in that time. So that's something I'm glad that I didn't live through. Not only that, but this picture that you see towards the top, this is in Toledo. You see folks sleeping outside. Why in the world do they sleep outside? There was no air conditioning in 1936. It started off with a lot of folks sleeping on their front porch, but the houses were just way too hot. The coldest spot they could find was out in the middle of the grass, out in the middle of the lawn, and close to nearby streets. And this is closer to downtown Toledo. And folks were just sleeping outside because even though the overnight temperatures were in the mid-80s, it's the coldest spot they could find. I can't even imagine what that would have been like. To make matters even worse, swimming was essentially off limits. Lake Erie and the Maumee River, the Ottawa River, was so full of bacteria at that point that it was unsafe to go swimming in those locations. Some folks that did got really sick. This was before we really started paying attention to the water quality going into Lake Erie and the Maumee River and the Ottawa River. So it was particularly bad. It wasn't a big algal bloom like we deal with nowadays, but it was a lot of E. coli, and these levels were off the charts. This is a map, too, during 1936 that shows anywhere it's in this really bright red. This is the hottest month that had ever happened, July 1936. The only reason some of these months here are not quite to record territory is that you had a couple of those months that I believe it was 1934, same Dust Bowl era, was also just about as bad. And to make matters worse, this is in the middle of the Great Depression. So it was just a really tough time. But if I had to go back and relive any of these big weather events, this is not the one I would pick. In fact, this is probably my least favorite to experience out of the whole bunch. But nonetheless, even on our hottest days, it's been a lot worse here in Toledo. Let's go to March 19th, 1948. On this particular day, the winds hit a record in Toledo, and some calculations there for a while, it actually was close or held a state record. The Toledo record wind gust was 87 miles per hour on that particular day there, March 19th, 1948. That was a remarkable gust of wind, and I'd have to check the records, but I'm 99% sure that was also from a severe thunderstorm that happened on that particular day there, right in the middle of March, almost the first day of spring. I told you March is a wild month. April 11th, 1965, this is probably one of the saddest days, most destructive days we've got in Toledo and Northwest Ohio history. It was the Palm Sunday tornado outbreak. There was several tornadoes that moved through on that particular day. And the big one that took the headlines and did so much damage in Toledo was this massive F4 tornado. And when we talked about tornadoes, we talked about how the scale goes from, it's either F or EF scale, depending on what year it was, but it goes from 0 all the way up to 5. And there was real debate on whether this was actually an F4 or whether it was an F5. I'm going to tell you something. There's not much of a difference between an F4 and an F5 tornado. It basically takes out everything above ground that there is. If you're in a basement, you're still fine. But this was a devastating tornado that moved through. It started out close to where the Franklin Park Mall is. It went all the way into Point Place and carved a destructive path along with it. There's another tornado on that night that took place that tried to move into Toledo, and that wasn't the only one in the area. I think we had at least six destructive tornadoes here. This is a map across the area on that particular night. I say day into the night. It was actually both. The small one here that you see, well, that was the F4 there in Toledo, but you had more tornadoes. These are actually two tornadoes. Basically took the same track here up into Michigan, and then you've got several tornadoes in the southern part of the area that took place. This track, by the way, that you see up into Michigan, this one goes all the way back with a cluster. There was actually a couple supercells that took that track. And you see how it goes all the way back into northern Indiana, close to Elkhart and Goshen, Indiana. The reason I bring that up is because one of the most famous tornado pictures of all time was from that same setup. Yeah, you're looking at this is an extremely rare situation, but you have essentially a double tornado that was rotating around itself, twin twisters, destructive twisters on the ground right next to each other. This was unbelievable. There was a newspaper photographer that was there, was able to capture this as it took place. And to this day, I've only seen or witnessed, personally, I've never seen anything like this, but from all the video and photographers that are out there chasing storms, I've only seen something similar to this one other time from a photographer that was out a storm chaser that was out in Nebraska in 2014. There was some twin tornadoes that took place with this, but this is the one towards Elkhart, and you can see the two big tornadoes associated with this. This is what is believed to be a tornado or potentially even twin tornadoes that was in Toledo. So on that storm, I told you it was an F4 tornado, close to F5. It's unknown exactly what was going on with this, but in this photograph, you see these two tubes coming towards the ground. The problem was it was dark when this came in, but it's possible that these were two tornadoes associated with that. It was never confirmed for sure if that was the case, but so it may not have been one tornado in that one storm that came through. It may have been twin tornadoes, kind of like what happened in Elkhart. So again, very historic deal, a lot of destruction, a very sad day and night on that Palm Sunday in 1965. Again, that was the worst tornado outbreak that Northwest Ohio has had. July 4th in 1969, only 4 years later, this was the worst weather day on July 4th ever, and I don't know if it's ever going to get worse than this. I hope it doesn't. It was a wild, severe event that brought everything with it. Damaging winds, large hail, flooding, rain, and tornadoes, and it happened right about the time the fireworks shows were supposed to get off, which meant there were lots of boats lined up out on Lake Erie. One of those boats ended up recording a 104-mile-per-hour wind gust. That was not associated with some of the tornadoes that were around the area. 104-mile-per-hour wind gusts, remarkable. And that was right on the edge there of Lake Erie. A wild, severe event there. Again, I mentioned there were tornadoes, but the big issue, flooding rain. 3 to 11 inches of rainfall fell in that storm, almost a foot of rain. And I think I've got a map showing that. This was not just Toledo. This is all Northwest Ohio. So this big derecho came through, and what it did was, here's the Toledo, clear on the edge of your screen. See the 104-mile-per-hour gust. Well, this line of storms went out, and then it stalled. And so in the eastern part of the viewing area, well, there's another 100-mile-per-hour wind gust right here, close to Lorain. Out towards Cleveland, it wasn't as bad. It was only 67 miles per hour. Still a horrific line of storms as they move through. But along with that, again, there was some flooding rains that moved in and took place. And so this is a map of the flooding rains. It was Ottawa County, Sandusky County, Erie and Huron counties. There was a zone here, and I'll mark it, but you've got Toledo right up here, which we had 4 to 5 inches of rain. It was way too much already. And then you had 10 inches, 11 inches up in that circle area. So again, Ottawa, Sandusky, Erie, and Huron counties got the worst of that. So just this severe weather event had literally everything with it on all angles, and it was really a frightening night. The fireworks display did not get off that night. January 26, 1978, well, this is the big blizzard of 1978, and it was, again, very similar to 1918. There was 6 to 18 inches of snow, winds between 40 and 70 mile per hour. But the strongest winds typically happen where there was lower snow amounts, and where you had the higher snow amounts, you typically didn't have the winds that were quite as bad. But this storm was awful. Doesn't matter how you look at it. I showed you the map for 1918. Low to the south, low to the north. They swept in like this. They collided right over Ohio, and then they came up here and started spinning around. That's exactly the same setup, almost to a T, that happened here with the blizzard of 1978. You see the 2 area low pressures here on that map. Going to the next map, you should see this, which is, I'll circle in where Toledo is again. We are right here, pretty close to that area low pressure. All these strong winds wrapping around that storm. This is after it collided into one mammoth, powerful superstorm right across the Great Lakes. So again, that was the blizzard of 1978. Going forward, we had quite a bit of snow with that system. But again, the farther west you go, the more there was. And it was hard to measure anyways because there was so much snow that actually fell with this whole thing. So here's Toledo, and we had about a foot of snow here. Wauseon had about 16 inches of snow. The Tri-State, about 2 feet, between 18 and 26 inches of snowfall. And then for Port Clinton, Fremont, Sandusky, Norwalk, Tiffin, 6 to 10 inches of snowfall. And you think, well, that's not terrible. That's not that bad. I guess. And then you factor in the winds, and then you realize, oh, yeah, that's pretty bad. We'll go with the green coloring on this one. You get into the orange shading where they had 6 to 10 inches of snow. There was 60 to 65 mile per hour winds. Look at Port Clinton and Sandusky. They were in the 65 to 80 mile per hour winds with this winter storm. And then there was a buoy out on Lake Erie that recorded 111 mile per hour wind gusts. And Cleveland had about 86, 87 mile per hour wind gusts right there that came in off of the shore. So yeah, there wasn't as much snow, but with winds that strong for a couple of days, you still had drifts higher than your house in some cases. So it was still a remarkable historic storm, no doubt about it. So again, in a matter of a 60-year time frame, you had the blizzard in 1918, and then you had this happen in 1978. Going forward, the drought of 1988 was going in 88, then going in even 89, pretty remarkably dry. And this, not as bad as the Dust Bowl, but it was bad through a lot of the country. And you look at that whole stretch of orange here, and that is drought all the way through the heartland. It was a bad, bad year because it did not want to rain. And when you get into your drought years and you don't get any rain, the dry air heats up even more. So it becomes this runaway problem. So if you don't get rain, the air heats up even more. Well, if it gets hotter, it dries the ground out even more. And dry ground heats things up. So it becomes this runaway issue. And once you begin to get drought conditions in June, before you know it, it can kind of take a turn on you. And by the time you get into July and August, you just can't get out of this pattern. And 1988 was about as bad as we've had on record. June 5th, 2010, this was a Lake Township EF4 tornado that happened again in Lake Township, and we're a little more familiar with this one. The 10-year anniversary of this is coming up very quickly, again on June 5th, just a few weeks away, an absolutely devastating event. Again, you got to put that one in the Palm Sunday outbreak of 1965 up there as some of the worst. And I got to throw this one in there. This might be the one historic deal that you might remember, depending on how old you are. It wasn't that long ago. At least I don't think it was that long ago. We go back 6 years ago, and that's when we had that historic year with snowfall. We had all kinds of things that seemed like it happened that year, but when it comes to the amount of snow that we had, we ended up with a record for the season, 86.3 inches. And here's the kicker. We had 5 major snowstorms of at least 7 inches or more. The first week of 2014 was historic. In fact, it's hard to imagine thinking back at it, but right around New Year's, we had, I think it was 11 inches of snow. We ended up with 13 inches of snow right after that. And within a matter of 2 days later, we had the polar vortex, and temperatures dropped to 15 below zero, and wind chill was 45 below zero. It was the worst cold we'd had in 20 years. So we had the worst cold we had had in 20 years. We had 2 of the biggest snowstorms we had had in years, and they happened right next to each other, and we almost had 20 inches of snow on the ground at a time. And then it started to warm up, and the snow started to melt. We thought, oh, okay, well, we got our winter out of the way, and then we just got hit again and again and again all the way into March. So that was one heck of a winter that we had. So that's the list that I've got of the Toledo weather stories and some of the historic years. Go ahead, and if you've got some of those questions for me, feel free to ask, whether it be about big extreme storms here or somewhere else, or maybe you've got some other questions from yesterday or last week or the week before that you haven't gotten answered. Let me know. Send me in those questions. Again, if anybody is interested in looking up more on these extreme events and looking back 200 years ago, or maybe it's 20 years ago, again, that book that I like so much, Thunder in the Heartland, and it's a book about outstanding weather events in Ohio, and it really is. And you go back and you end up reading there's a lot of Toledo Blade articles in here when it comes to some of the big events that we've had. Covers drought, winter storms, heat, severe weather, tornadoes, all kinds of stuff, and cold weather. So it's really interesting if you are kind of into that. So again, today we kind of mixed in obviously world weather, but we also mixed in some weather history. So I guess not only was it a science lesson today, it was a history lesson as well. Again, next week we'll talk all about the changing seasons. We'll talk about summer. And is there something else that you want to talk about, weather-wise or science-wise, that I haven't gotten to over the last 8 to 9 weeks? Let me know. Send me a comment, send me a message on Facebook, and we'll see what we can do on trying to incorporate that next Wednesday for that final week. Let's see what we've got here question-wise today. Was that bad winter in 2013, 2014 a result of El Nino, La Nina, or was it a fluke? Great question, and you just tied in everything we talked about yesterday, so I'm proud of you. It was a great question. Here's the deal. That was a La Nada year. So yesterday we talked about how El Nino usually is warm and dry. La Nina is usually warm and wet. But if you don't have either one of those patterns, typically it's cold. Sometimes it's snowy, but it's typically cold. And that year, it was a combination of things. It was a La Nada year. So already we were vulnerable to big Arctic outbreaks. So that helped out. The other thing that happened that year is that the Gulf of Mexico and the Atlantic Ocean were warmer than average. And so with that, and not only that, the Pacific Ocean outside of California was warmer than average. So what that ended up doing was the Gulf of Mexico and the Atlantic Ocean, that extra warmth helped provide some extra energy. It helped provide some warmer than average temperatures, or at least it tried to, across the southeast part of the country. So there was some resistance there already to the cold air coming in. That was important. The other was that the warm waters out towards California, that whole stretch all the way up to the Gulf of Alaska, helped promote some warmer air out there. So there's a ridge there. You basically had a ridge down to the southeast, and that created this large trough in the middle of the country. So now we had the perfect setup when it came to that La Nada, which helped out. We had a perfect setup, which seemed to be with those warm water temperatures in the Gulf, the Atlantic Ocean, the Pacific Ocean. And then the polar vortex was fairly weak. And so we had all of those check marks that were leading us to a vulnerable year. So we had big blast after big blast of cold air come in, but we had a really active jet stream with a lot of moisture along with it that was pumping in all of that. Now, here's the thing. This year, back in November, we were looking at it going, uh-oh, we may be in trouble again for this coming winter because we have a La Nada or a weak El Nino setting up, and that's what happened. We also have that same temperature profile with the ocean water setting up again. So it really comes down to the polar vortex. And what ends up happening? The polar vortex was so strong that it didn't allow any of that Arctic air to move out. Had it moved out and moved into the United States like it did back in 2013, 2014, I think it would have been a wild winter all the way through the season. It just didn't happen. The polar vortex is almost the opposite of what happened 6 years ago. So all those factors work together, and the lack of an El Nino and La Nina was definitely part of it, but there was a lot more to it in that given year. So that was a really, really good question. Thanks for asking that. Why is Toledo, let's see, Allison asking, let's see, why is the Toledo warm thing so dangerous? I'm going to, Allison, let me know if I'm misinterpreting your question, and if I am, just ask it again. But I'm going to assume it was probably back in the 1936, that week of really hot weather is what you're talking about. I showed the picture of Toledo and how folks were sleeping outside. The heat can become a big issue when our body temperature likes to be in a certain range, right around 97 to about 99 degrees, kind of in that area there. And if we're cool, we can throw on some extra layers and can warm up and stay fairly warm. When it gets really, really hot, it can be tougher on our bodies to get acclimated to that, because other than sweating, we don't really have any other natural ways of cooling down. And then if you're sweating, you got to drink lots of fluids and keep up with it. But it can be really difficult to sleep. Because it's difficult to sleep, it can be difficult to get any rest. And when it happens day after day after day after day, and there's no air conditioning whatsoever, there's no efficient way of cooling off, you can't go swimming because the bacteria is dangerous into the waters and into the lakes and that type of thing, it can be extremely difficult to cool your body down. And so for some, they can deal with the heat a little bit better than others. For others that are especially sensitive to the heat, or they're outdoors working harder and harder, your body temperature can jump up so much to where you can go into heat stroke or heat exhaustion. We are going to talk more about that next week, because it's going to pertain to our week of summer and extreme heat, and why things are so dangerous and how that affects the body. But that's the big issue with that, is that if it's a little cooler, our body can usually adapt to that a little bit better generally than if it's really hot. Now, if we would have had air conditioning in the 1930s, it would have been better. But even today, even when we had air conditioning for the most part in 1995, when we had a massive heat wave come across the Midwest, and it was bad. We had more humidity than 1936, but it wasn't quite that bad. And it led to so many problems from Chicago all the way through Toledo up into Michigan. So extreme heat can be a big, big problem that we don't think about a whole lot about. And I'm not really a fan of extreme heat anyway, so I definitely would not have wanted to go back to that point. Let's see, Jessica asking, let's see, is there going to be a thunderstorm tomorrow? So, yeah, tomorrow we're looking at a better chance of thunderstorms because we've got the better ingredients coming in. It's been so cold as of late, and actually this is a classic setup. We talked about this a few weeks ago, how we can look at those clouds and kind of get an indication of what the weather is going to do. Well, I think if you're out close to sunset tonight, 6, 7, 8 o'clock tonight, you'll probably start to see some of those high clouds come in. And remember, that could be a warning sign that there might be rain on the way within 24, 36 hours or so. And I think overnight tonight, we're going to get mid-level clouds. I think by tomorrow morning, we might actually have a few showers. And then by the time we get to midday, we'll have storms. So there's a warm front trying to move northward. It's trying to push that cold air out. Well, it's going to battle up against that cold air. The cold air does not want to leave. The warm air says it's time to go. So the warm air is going to ride right over the top of that cold, dense air, and that's going to allow showers, clouds, and potentially some thunderstorms. There might be a few strong storms, but right now it doesn't look like the instability is too bad for that coming up tomorrow. But now we're starting to get into that spring pattern where we're going to have warmer weather, more frequent showers and storms, it looks like, going forward. Okay, let's see here. What level of earthquake can shake the ground 120 miles away? This Courtney was asking this question. It doesn't actually have to do with what level of earthquake, because out in California, and they have these large mountains, and these earthquakes typically happen pretty deep underneath the soil and underneath the rock. And the way things are set up, a lot of times the violent shaking might go out 50 miles or something along those lines. It's usually very confined, very close to where it takes place. In the eastern part of the country, we don't have to worry about earthquakes as often, but if we get a big earthquake, it usually shakes for hundreds and hundreds and hundreds of miles. So you could have a 6 or 7.0 earthquake happen, say, in St. Louis. If it's a 7.0 earthquake, we're almost definitely going to feel it here. And St. Louis isn't very close to home. You get that to happen out in California with the way the topography is, the elevation, the mountains and all that. And that violent shaking doesn't go that far away. So it doesn't really have a whole lot to do with how bad the shaking is. It has a lot more to do with how deep into the ground that earthquake happens, what kind of topography is all around it, on how the vibrations and the movement of the earth actually get up to the surface and how it affects everything. Okay, let's see. Is there a term like El Nino or La Nina used to describe years when the Gulf of Mexico is warmer or colder? That's a really good question. Or is that typically less significant of a weather influence at El Nino and La Nina, so they don't name it? Yeah, it's the latter. It's the one that you just mentioned. Usually it's not as, it's significant for us. I mean, it has an impact. I would place that factor. I always consider that factor when we look at a winter weather outlook, or if I'm just trying to get an idea of what the overall pattern is, because it definitely plays a role into what even our spring sometimes can look like, but definitely our winter, if those water temperatures are above average in particular. But it doesn't, outside of the eastern half of the country, usually doesn't really have much of an impact around the globe. To where El Nino and La Nina, that just has, it's like this domino effect that's 5,000 miles away from home, but when it gets triggered, it has this ripple effect all across the globe, and so that's why that one gets named. Now, we do look at charts and see kind of where it's at, where it's trending, how it compares with the past. So we look at, basically a chart of is it above normal, is it below normal, but it doesn't have a name to it at this point. If you want, you could probably name it and you let us know. We can give it a nickname or something. But yeah, at this point, there isn't. When it comes to meteorologists around the world, we don't have a specific classification or term for it at this point. Let's see, why has the weather seemed like it's been behind for the past 2 to 3 years? I'm going to assume you probably mean that the weather's been behind kind of on a seasonal basis, meaning, I mean, my goodness, it has felt like April as of late, and we're in May, and summer heat, it takes a while, it seems like, to kick in, but now it's lasting into September and even early October, and our fall seem warmer than average, at least the first half of it, and winter seems like it's sluggish to start, but then it doesn't want to quit. So I'm going to assume that's the question that you're asking. I don't have a specific answer of why that's the case. There are a couple theories that I have, and this hasn't been proven. First of all, I will say that it's not just you that's noticed that trend. I've noticed it, and we've gone back in the weather data, and we've been able to confirm this by looking at the severe weather season. The severe weather season used to peak in April, May, and June, and it didn't really come back much into the fall. Now it's more like late May is when it seems like it's kicking off. June and July are kind of the peak months, and it's still there in August. So our severe weather season is almost more during the summer season now. Our summers have been wetter and stormier. But then when it dries out, it really does seem like everything's delayed. Anyways, we can go back, and we've been able to confirm this by looking at storms, by looking at heat, by looking at the hottest day, by looking at the monthly averages. It all shows up. And it's not just over the last 2 or 3 years. Quite frankly, it's more like the last 10 to 15 years. It's been a trend there. You go back in the weather data, a couple more decades, and you don't see that at all. It's the total opposite, to where the seasons are kind of starting on time or maybe a little bit earlier. You go back far enough, and you kind of see this push again. It's a little bit later for it. In fact, let's see, I don't have enough time and probably to pull it up real quickly here, but we've got a whole chart of records, and you get back far enough and you kind of see this happening again. So I have two theories. My first one, and I think this one has something to do with it, it's more of maybe a 20 or 30 year pattern that kind of oscillates back and forth. And I think there's something to that. Why? What? I don't know. What is the pattern? Why is that pattern happening? I don't have an answer to you, but I think it's a natural cycle, 20, 30 years. It kind of fluctuates back and forth because that's what we see in the data. The other is that with the Arctic ice, with the amount of it shrinking in the Arctic, it is possible, at least this theory makes sense, this has been floated out there, is that late fall in particular has been quite warm. Early winter seems to start off real sluggish, but January has had some notable cold blasts, and January and February snow amounts are above average. So once that cold air, once the winter finally kicks in, it really kind of seems to start to make up for lost time, but yet we're not seeing it very often in December like we used to, or even November, although we did have some snow this past November. So the theory is that with that Arctic ice shrinking up, it's taking more time for that ice and snowpack to build up in the fall. But then once it finally does build up, then you're seeing with the ocean water temperatures tending to be a little bit warmer compared to where they used to, you're seeing the middle of the country being impacted a little bit harder in January and February. Again, this is looking over the last 10, 20 years, looking at trends, not necessarily last winter or the winter before, but overall trends. So the lack of Arctic ice might be playing a role going into that late fall, early time frame into winter. It may also have an indirect role why we can't get out of winter, and perhaps that's kind of setting up a domino effect through the year. But with that said, and I think that theory is a good possibility and it's valid, I think that there's some other natural variable there that I don't really know what it is or why it's taking place, but you just kind of see it show up as you go back into the decade. So hopefully, Tim, that answered your question all right. And if not, let me know, and I'll try to do a better job at it. So thanks for everybody watching and tuning in today, despite some of the technical issues that we had right at the beginning with the audio and trying to start a few minutes late. Next week, again, we'll talk all about changing seasons, summer, extreme heat, and whatever else you guys want to talk about. So let me know what topics sound good to you. We'll see you later. See you later.